Looking for integers a and b that are solutions to this summation equation where we have a constant. Notice that this has no dependency on I. The index of the summation is I. We're just summing up a bunch of ones, and we want to know what values of a and b will produce this value of 262. Now, something that's worth noting right now is that this is squared, so you're going to end up with squared terms in this thing. So do note that I think 16 squared is 256, and 17 squared is greater than 262, right? I think 17 squared is 289. But it'll limit our search a little bit. Okay, let's move along. Now, the big idea on this problem is this result. It's actually a homework problem from a Charles Vanden number theory course. And let's just take a look. We're making an assumption here that m is greater than or equal to n, which is a reasonable, looking assumption. And just notice that if we picked, let's just make one up. What if we did summation I equals, let's say, 4 to 6, right? And we're adding up ones, not i's, right? This is a 1, a big fat 1, all right? Well, this is equal to 1 plus 1 plus 1, which is 3. And it's tempting to want to just say it would be 2, but that's why we have to add this 1. So this is equal to 3. And so notice that's equal to 6 minus 4 plus 1. I'm writing small here, 6 minus 4 plus 1. And so this special case certainly holds for all the other integers too, right? So that's where this result comes from right here, this odd-looking result. Again, it was a homework problem in Charles Vanden's number theory course, the green one, famous green one with the gold letters on it. Okay, so because of this nice result, we can rewrite this, our problem. This is our original problem like this, right? Okay, or this is your m. This would be your m, this would be your n, and this would be the one that you see right here. You just line it up with this, okay? Now, another nice thing about this is that this is equal to, from well-known algebraic identity, a plus b quantity squared is a squared plus 2ab plus b squared. So the 2ab's will cancel, and you'll end up with a squared plus b squared plus 1. All right, folks, this all craps out. It's designed, all math problems are designed to work out reasonably nice. Okay, so the 2ab's cancel. And remember, what was our magic number? 262. So we want to know, when can this equal to 262? Okay. Now, yeah, I'm not claiming the solution that I have here is unique. But notice that we won't have to go any higher than 17, right? Since 17 squared all by itself is bigger than this number. Well, maybe it would work, though, because you're subtracting something off, right? But just to get some idea where to start, you could try a number like 14 squared. Okay, so 14 squared is equal to 196. But I don't think there's any squares, okay, that you can add. I can't think of any that's going to give you 262. Okay, and you guys can experiment with that. 14 squared is 196. You can check the other squares, and I don't think you can get 262. But one that I already know that works is 15 squared. 15 squared plus 6 squared plus 1. Yeah, there's a lot of, checking and stuff that you can do arithmetically, but this would be 225 plus 36 plus 1, right? And so that's 30. So that would be equal to this number, right? 262. Okay. So what we know is that a pair of solutions would be a equals 15. Now, I don't think there's any others, but there might be. I don't have any reason to think there's not any others other than it's just the squares are kind of spread out, But so a equals 15 and b is equal to 6, or a pair of solutions, or a solution pair, whatever you want to call it. Okay, so That's the answer I got. And again, I purposely did not say there's a unique solution. I tend to think there is. The same thing would work for minus 15 and minus 6, right? So so it's not a unique solution, but if we're thinking about positive integers, I think this might be unique, but you guys can explore this one if you feel like it. I'd like to know the answer to the question. This is an answer perhaps not unique. Okay, thanks for viewing.